We went to south of the border.
I got a 0 for that, by the way.
I had the date wrong on it. All right, let's look at the circuits. Give me questions about, I'm on the first page. I'm on, okay, so I'm ignoring, I'm on the circuit. Because that's really, second one down, right or left?
No, we did not do
No. Which second one down on the right or the left? Okay.
Well, I did it.
Yeah. Okay, so I expected you to have trouble on that. The reason is I wanted you to think through that. I'm going to teach you tomorrow, actually. We're going to talk about rules of this kind. Yes, you would have to graph it and think about the two sides.
So I did it right.
You'd have to, and that's why I put on here, the one that I did, I put you a little sketch of the graph because I wanted you to think about it graphically. Is it a jump? If it's a jump, it's not continuous. Is it a hole? If it's a hole, it's not continuous. But let's look at this one. This is the second one down. It should be number 11 for you. It's the one that says D and E for the answer. And it says, given this, it has a hole where? So remember, holes are where both things cancel top and bottom. So if I were to slash this and group it, I get x squared times x minus 4 plus 3x minus 4. Second one on the left side, x minus 2. Yes. So this would tell me there's a hole at positive 4. Do I have any, bless you, asymptotes on the horizontal or vertical asymptotes? I'm sorry, bless you.
What circuit are we talking about? Because I don't think we have the same circuit.
Look at this one, the second one down on the left side. I've got a hole at x equals 4. They didn't ask for this, but I also have a vertical asymptote at 2. That's exactly right. Yeah. What? Oh, on GoGuardian. Do you have your computer up now? When you pull up, if you'll pull it up, I can go. It's easier if like you're trying to access the block site, and then I just hit unblock. While we are here on this nice, beautiful, rational function, we're getting ready to talk about this too. So just as a refresher, what about horizontal asymptotes for this one? I do what at the top? How do you tell horizontal asymptotes of rational function? Top heavy, bottom heavy, same. Top heavy, no horizontal asymptotes. Bottom heavy, y equals 0. Same, dividing by the leading coefficient. We'll refresh on that whenever we get there here in another day or two.
It's top heavy, so it's.
This one's top heavy, so no horizontal asymptotes on this one. Second one on the right. With the radicals, the limit as x approaches 0 of the square root of x plus 3. Yeah. Okay, so I see radicals. I know I need to rearrange and do some algebraic manipulation, so I'm going to use what? So if I do conjugates here, I'm going to FOIL up top, right? I get x plus 3. This one and this one are always going to cancel if they're conjugates. Minus 3. Over x times square root of x plus 3 plus x square root of 3. Literally start canceling out. Literally. Well, 3 minus 3 is 0. And then I can take an x out of everybody, right? So I end up with 1 over the square root of x plus 3 plus the square root of 3. And now Remember, the whole goal is getting it to where I can plug that 0 in for x. And I can now, so I get 1 over the square root of 3 plus the square root of 3. Yeah. So if you put that on your calculator, that's what you get on the calculator.
It's still not here.
Yes, it is.
It's still not here.
Yes, it is. No, that doesn't look good. That's right. Number 5, what was that? Out.
This is a good one. Yeah. Depending on where the conjugate is, if it's the conjugate of the top, yeah, everything's it depends. It depends on what you started with. But the radicals will all be gone when you do the conjugate. But yeah, 289. I'd prefer them leave it. Yeah, I'd prefer them leave it exact. What? The one with delta. So I will tell you, pay special attention to this one. Delta is this. It's just a variable, right? If this were, you did a lot of these with h instead of delta x before. It doesn't matter what this is. It's the same process. Treat it just like the variable that it is. Don't get so caught up in it being a delta x. One of our formal definitions is going to use delta x. The other one will use h. On this one,
This is your work right here.
all right, the triangle, just look at this. This is just a variable. You could put a y in there if you wanted to. It doesn't matter.
My issue was,
Because one of our formal definitions uses delta x. It is change in x, but you don't have to. You're looking at the change in x as a variable. So,
delta x out of nowhere.
no, if I FOIL this out, right?
Oh, that's why, yeah. That's all right.
I went down below my box. Minus 12 minus 3 delta x minus 4. So now I'm going to start simplifying. 16, negative 12, and negative 4 cancels. That gives you 0. Then I actually, because I'm lazy, I go ahead and take a delta x out of everybody now, because I see that they all have one. If you need to write it, by all means write that. 8 delta x plus delta x squared minus 3 delta x over delta x, and now take a delta x out of everybody. Whatever way you do that. Or you could have combined the like terms first, 8 and negative 3. No. Yeah.
You could just not show up.
I can put a 0 in there and just get 5. Let's get 5.
It's 5.
5. It's just 5. Because now if I put the 0 in here, don't let them, because it's symbols like this, don't let that confuse you. Treat it like a variable. Yeah. So I got a note here to look at your calculator if you don't remember about graphing these kinds. If you were to graph this, you would find, because this bottom becomes x minus 1, x plus plus 1, right? So I've got asymptotes at 1 and negative 1. And if you graph this, you'll see that this graph does something like this. Good morning. Thank you so very much. Breakfast, y'all. Thank you. Wyatt is excited about the juice. As x approaches negative 1 from the left, I'm going down. That's why it's negative infinity. That's okay. What about the other side? Not necessarily for that one if you remembered how to do it, but if you didn't, it'd be okay. The first two. All right, let's see. Look at the bottom. It says, where does it have a vertical asymptote? Yeah, I used to go to ones that are like. I ain't gonna lie. Copy's mine. So these would probably be non-calculated questions. All right, so this is asking me for vertical asymptotes, so I'm just going to factor. The point of this is, do you understand the difference in a hole and a vertical asymptote? Here there's a hole at 3, but there's a vertical asymptote where? Negative 5. There. I was trying to speed in and out. Okay, so if it cancels top and bottom, that's a hole. Then you take what's left in the bottom and set it to 0, and that's your vertical asymptote. Yeah, now I know what that means, so don't say it anymore. No. Shouldn't say that. All right. And then you say which other one? The other one at the top? Oh, the continuity. So if you think, stop talking about him, he's not nice. If you think about piecewise and what it means, okay, and you think about what continuous means. Continuous means, by your definition that you know so far, and you're fixing to learn a fancy one. I cannot pick up my pencil, right? I draw it without picking up my pencil. So we know that cosine on its own is continuous. Yes, that is a continuous function. X squared plus 1 on its own, that's a parabola shifted up 1. Continuous on its own, yes? The only point of possible discontinuity, which is either going to give me a hole or a jump, is going to happen where? At 0. Why? That's where it's cut off, right? One's less than, one's greater than. They're going to go in different directions. So the question is, are they meeting at that point and sharing that point? Or is it jumping up to another one? How could I possibly tell?
Calculator.
Just plug in 0. Don't make it harder than it is. Right? If you get the same thing, what's the cosine of 0? 1. What is 0 squared plus 1? Continuous. They must share the same point. Now, if you didn't understand that and couldn't draw that conclusion, if you graph them, cosine of 0 is 1. That's an open dot. It's coming off like this. And then this is a parabola, but this point is included and it's going up. Is it continuous? Yes. Okay. That's a multiplication table. And we'll use that every day. What? 16? The limit is X purchase one to the right.